Hi again, welcome to part 2 of the real numbers lesson. This is on the back side of the real number system notes that you were to fill out. So hopefully you have watched part 1 before starting part 2. In terms of this page, I would read through the directions and actually take some time and pause the video and see what you can answer here on your own. Give this a try and see if it makes sense. I'll give you a little bit of direction before I'll tell you where you should pause the video, and then after you've attempted it on your own, I would tell you to then come back, watch the video, and double check your work according to what I have done here. So the first part, it says place the letter of each value in its location in the real number system below. So if you base it off of the chart on the front, remember you're trying to find the most specific classification for these numbers. So that letter, like letter A, is the number 7. 7 is one of those counting numbers, so the most specific classification for the number 7 would be natural, which means I would place the letter A in the natural category. And then I would continue that with each one of these. Be sure to simplify the expression if possible. For example, in letter B, negative 36 over 12 is actually equivalent to negative 3. The same thing here for letter C. Negative square root of 36 is actually equivalent to negative 6. And there's one other one here. If you get down to letter K, you really should take the square root of the top and the square root of the bottom. So the square root of 4 is 2, and the square root of 81 is 9. So this crazy looking expression, letter K, is actually equivalent to 2/9. You will notice the rest of the page has some multiple choice questions and some sections where you are to give an example. So again, see if you can place these numbers in the correct location. See if you can answer the multiple choice questions. Take a moment and pause the video now. Answer things on your own, and when you think you have everything answered, come back and watch the rest of the video as I go over the answers here with you. Okay, so letter B, negative 3, we would refer to as an integer. So you should have the letter B in this second circle. The same thing for letter C. Negative whole numbers are included in the integers. So C would also be an integer. Now we actually used the example pi. Pi is a decimal that does not have an end. So that puts it in the irrational category. 6.48, it's a decimal that ends. It would be included in the rational group. Rational numbers include decimals. Negative 2, another integer because it's a negative and it is a whole number. Negative square root of 10. If you would type this in the calculator, it is a decimal that does not end, it does not repeat, so it belongs in the irrational category. The number 0. 0 has a special classification. It is the one number that is only considered to be in this whole number category. All other whole numbers are actually natural numbers. I, 2 and 1/6, this is a fraction. So this fraction should be included with the decimals in the rational number category. Letter J, negative 0.7 repeating. Repeating decimals have a pattern, so they would be included in the rational category. And then letter K, 2/9, again is a fraction. So fractions and decimals are rational numbers. So please make sure that your letters match the letters I have placed here in each one of these circles. Again, I put it in its most specific classification, and you'll notice the way that these circles are drawn, the letters are included amongst every category above it. So really, letter A, even though it is a natural number, it is also encircled with whole, integers, and rational numbers as well. Okay, for the multiple choice section, which expression does not name an integer? So -15 is an integer. It's a negative whole number. 0 is a whole number, which means it's also an integer. 12 divided by 6 is actually 2, which means it's a natural number and therefore an integer. So the only one that doesn't fall into this integer category is this fraction 6/14. Fractions are rational numbers. They are not integers. Number 2, which expression represents an irrational number? So irrational, we have a repeating decimal. That is rational. We have a fraction. That is rational. We have the square root of 3 minus the square root of 3. This would actually equal 0. That's a whole number. So the only one that makes sense as an irrational number is letter B, the square root of 75. Number 3, which number is not a whole number? So again, not a whole number. Make sure you simplify any answers. For example, 18 divided by 3 is actually equivalent to 6. So we have 8, 0, -10, and 6. And hopefully one of those jumps out at you as the answer. Negative numbers are not whole numbers. So letter B would be the answer in number 3. Number 4, which of the following is a true statement? -9 is a whole number. Well, we just said negative numbers are not whole numbers, so A would be false. The square root of 25 is an irrational number. Well, the square root of 25 is actually 5. So 5 would be a whole number, not irrational. B is out. 0 is a natural number. Well, hopefully after watching this lesson, you know that 0 is a whole number, but it is not a natural number. So C is false. That leaves us with D as our last and final answer, and we see 2/3 is a rational number. Fractions are rational, so 2/3 would be a rational number, making it a true statement. Number 5, which of the following statements is false? Be careful how you read these. Letter A, all real numbers are rational. Okay? Well, real numbers include two things, rational and irrational. So they are not all rational. And if we are looking for the answer that is false, I think we might have found it. A would be false. Now, just to clarify, if we look at B, every integer is rational. If you look at your chart, integers are included amongst the rational circle, so that makes sense. Natural numbers are integers. Whole numbers are real numbers. If you look at the circles, natural numbers are encircled by integers, whole numbers are encircled by real numbers, so they are part of those other categories. Okay. Now your answers for 6, 7, and 8 could vary, except for number 6. Number 6, there's only one option. Give an example of a number that is a whole number, but not a natural number. There is only one of them, and hopefully you are recognizing that it is 0. Number 7. Give an example of a real number that is not rational. Okay, so that means we're looking for an irrational number. You could use pi, you could use the square root of 2, you could use the square root of 5, you could use the square root of 10. There's many options there in number 7 that you could include, but they have to be an irrational number. And then number 8, there are many options you could have written down for number 8. It says, give an example of a rational number that is not an integer. Remember, rational numbers include fractions and decimals. So if I wrote a fraction down, like 2/3, that would work. If I wrote a decimal down, like 1.5, that would work. If I wrote a repeating decimal down, like 0.6 repeating, that would work. So anything that was a decimal, a repeating decimal, or a fraction could be included as an answer for number 8. Please double check your work and make sure that you have included and answered 1 to 8 correctly, as well as filling in the circles here at the top correctly. And if that is the case, then you are completed and finished with today's lessons. We will talk more about real numbers as the week goes on. Thank you for listening.